1.2 Algebraic expressions and models is what we are on right now.
I feel like I'm taking crazy pills.
Numerical expression. It has numbers. Okay, so that's the first thing to keep in mind. We're talking about a numerical expression. It has operations. It has symbols. It has letters in it, but no equal sign. When we talk about expressions, there is absolutely no equal sign involved. Okay, so we're just talking about letters, numbers, and variables and operations, but we are not talking about any equal sign whatsoever in an expression. So 2x plus 3 is an example.
You're trying to get crazy with it.
So a definition here. We have 2 to the 5th power. And first of all, for some reason, some of you seem to magically think that all we do here is 2 times 5. For some magical reason, the math teacher just decided to write the 5 really, really small and put it up in the air. So we still want to multiply. That's not the case. Okay? The answer is not 10 here. What that's saying is you take 2 and you multiply it 5 straight times in a row. That's an exponent. You would say that as 2 to the 5th power. That means 2 times 2 times 2 times 2 times 2. So your actual answer to this problem, meaning that 2 is your base, that's the large number on the bottom, that 5 is your exponent or your power, that's your small number.
Do not go in there. Woo!
But either way, 2 to the 5th power is 32, not 10 like most of you seem to think. Example 1, negative 3 to the 4th means you're doing negative 3 times negative 3 times negative 3 times negative 3. Well, you can kind of group these together if you want, right? You can do that in your head. Negative 3 times negative 3 is 9. So negative 3 times negative 3 is 9. So we get 9 and 9. And what is 9 times 9? I hope most of you know this. That is 81 as your answer. Now, the reason I'm showing you this is there is a huge difference. A huge difference in these two. Negative 3 to the 4th power is saying negative 3 times negative 3 times negative 3 times negative 3. Negative 3 to the 4th, when it's not in parentheses, I'm only taking the positive 3 4 times in a row. So really what this looks like is I have a negative, then I have a 3 times 3 times 3 times 3. Okay, that's what it really looks like. The negative is there on the outside. I take the 3 4 times. Up above, because this was all in parentheses, I took the negative 3 4 times. But down here, I take the 3 through 4 times because it's just the 3 that's the 4th power. So really this is negative 9 and positive 9. So negative 9 times 9 is negative 81. That's the difference between those two answers. Order of operations, P as in parentheses, E as in exponents, M as in multiplication, D as in division, A as in addition, and S as in subtraction. Please excuse my dear Aunt Sally. Some math teacher created that probably back in the year 1902, for all I know. I have no idea, but either way, everybody and their brother knows this. So I'm really surprised and shocked if for some reason you guys do not know this. And if you don't, maybe you know your own little mnemonic device in order to remember this. But either way, the point is you need to remember it. Okay, you need to remember order of operations. And it goes please as in parentheses, excuse as in exponents, my as in multiplication, dear as in division, aunt as in addition, Sally as in subtraction.
If you can dodge a wrench, you can dodge a ball. What?
So let's take a look at this example in example 2. Okay, we need to do things in parentheses first. So I'm staring at this problem going, oh look, negative 16 and 2 is in parentheses. So let's get rid of that. So I do by making that negative 14. So I have negative 14 and a negative 3. On top, I have a division sign, and I have 24 minus 3. Now, even though that's a division sign, when you're talking about fractions, what I want you to do whenever you see a fraction, as in a numerator and a denominator, solely look at the numerator and do everything to the numerator. Then solely look at the denominator, do everything with the denominator. Then divide them at the end as that fraction and get your fractional answer. So, according to order of operations, next would be exponents. There is no exponents. Next would be m for multiplication. So let's multiply negative 14 times negative 3 and get positive 42. Next up would be division. There is a division. We cannot divide those two separately. So before we do that, we need to combine them. So 24 minus 3 is 21. Now I can divide them. 42 divided by 21 is 2. So let's take a look at this one now. We have to do P first for parentheses. So I change this 2 plus 9 into 11. That's how I got that 11. Then I look at this, please. Excuse, there is no excuse for E. My, there is no M for multiplication. Dear for division, that's why I have this here. So let's divide those. And when we divide them, 21 divided by 3, I get 7. My dear division, yep, we did that. Aunt, there is no addition. Sally, I just subtract them all together. So I just go down in order. 16 minus 11 is 5. 5 minus 7 is negative 2. Okay. Example 3, doing these. Now we want to do everything that's inside the parentheses first. Great, wonderful, no problem, except inside the parentheses, then we need to do order of operations again. So inside the parentheses, there is no other parentheses, there is no exponents, but there is multiplication. So we do parentheses first, but still do the order of operations inside. So we get a 35 there, right? Because 5 times 7 is 35. 15 divided by, because next inside the parentheses would be division. So I get 15 over 35. So now I have to look over here and I see multiplication. So 4 times a half is 4 over 2. So what I can do is I can divide each of those by 2 because I can take a 2 out of both the top and the bottom. I can divide each of those by 5. And when I do that, I end up getting a 2 over here, right? Because 4 divided by 2 is 2. I can simplify 15 over 35 to 3 over 7, so I get 2 over 37, which is a mixed number. How many of you remember how to switch a mixed number into an improper fraction? This says a little review on that. We would do 7 times 2 and get 14 plus the top 3, and we would get 17 over 7.
Hey, Doc, we better back up. We don't have enough road to get up to 88.
Roads? Where we're going, we don't need roads.
So when we come back here, let's finish up with 1.2 with expressions.